All right, large-scale stunts and physics fun. It's all happening at the U of M right now. We're talking about the Physics Circus.
That's right. It presents its largest public show of the year, and Emma Roscoe joins us with a little preview. It's called the Physics Circus, and it's at Northrop Auditorium. Emma.
Well, welcome to the stage at Northrop Auditorium, where the public performance of the Physics Force Physics Circus is going on at 7 p.m. tonight. Tickets might be available. Look at Eventbrite for that. I'm joined by Shaul Hanani, and you're a professor of physics here at the U.
That's right.
I draw your attention to the boiling flask. And what is going on down there?
So we have a boiling flask here. As the water is boiling, the mist, the vapor pushes the air out. So what I'm going to do is I'm going to demonstrate the effect of air pressure. What I do now is I put the flask inside, the tube inside, the mist here condenses, and there's no air. We have a bucket of Kool-Aid here, and air pressure pushes on the Kool-Aid. There's air pressure pushing on the Kool-Aid, and there's less and less pressure inside because the vapor condenses. As there's less pressure here and end pressure here, you could see the Kool-Aid going up the tube, and soon enough we'll see what happens when the Kool-Aid gets to the top. And right here's the Kool-Aid up, and we have this fantastic fountain, and you can see Kool-Aid is going to go all the way through until it fills up the entire space where there was no air before. All of this demonstrates the effects of air pressure and the fact that the atmospheric air can push the Kool-Aid up all the way up to the flask.
While we look at some of the other experiments we did this morning, for instance, the fire extinguisher one, which shows that when you throw molecules in one direction, you're going to get an equal and opposite reaction.
Correct.
Shaul, tell me about the importance of reaching kids. You're reaching some 30,000 kids this week.
Correct.
All week.
Yep.
With the Physics Force. Why is that important?
It's very important to get kids, families, adults comfortable with science. Science is so important for our society these days, and you want to get this comfortable connection with science early on, and to show kids and families that science, particularly in this case physics, is not complicated or difficult. It's fun. You can do a lot of fun with these things. That gets families and kids comfortable with science.
Well, I sure had a lot of fun this morning. And I'm going to leave you with a really interesting statistic. Something like 10 years ago, there were like 2,500 applications for 800 freshman spots in the sciences here at the U. Well, last year there were something on the order of 13,000 applications for 1,000 open slots. So I think that the Physics Force is getting kids excited about science. Back to you.